Okay, students, we got everything. Just disconnect one of them and that'll be good. And actually, can you get, how many, and how many, and do we have 27? Okay, so good. All right. So bring one of the regular boxes down here for me to demonstrate with. Okay, students, as you can see, we're kind of getting all these circuit boxes ready up here. I wish we had a little bit of prep time, like 15 minutes before class starts, between the previous class leaving and us getting in here. We could do all this stuff then. Okay, what we're going to do, circuit combos for the first part of class. And then I'm going to give you some more discussion and theory about discharging and actually loading capacitors. And then we'll finish by talking, hopefully, about oscillation. I'm going to give you some reading homework tonight. And so what that means is read ahead and look for my annotations and try to make use of that. So let's look at our task. Go ahead and write this down. The three things that we're going to do today, which we're kind of messing around with up here, is we're going to do a single bulb, 2 D cells. We're going to bring 2 D cells in today instead of just one. And then we're going to measure the current in the battery. So we're going to be into the batteries. So in other words, between the light bulb and the batteries. Okay. And then we're going to put in a pair of bulbs on parallel branches with the 2 D cells and analyze that. And then let me get my notes here. And then the third thing we're going to do is put those 2 parallel bulbs into series with the third bulb. All right, so we're going to use all 3 of those green light bulb brackets. And then little typo there, into the battery. We're going to measure the current into the batteries. So, and I want you to have your clickers ready because you're going to make some measurements and then we're going to collect your guys' measurements on iClicker. But I want you to write them down too, you and your teammates. All right. So let's get ready to hand out the boxes. Come up, 1 for each team of 3 or team of 2. Get a box and a fluke. And I'm going to pause the YouTube. No, I better not. Can you push up that? Can you bring me that chair, that really tall chair? I don't know, feel like I'm sitting on the floor like some of these other chairs. I know, this one I think is at max, so. All right, thank you for that. Okay, and I've got one over here, right? Oh boy. Did you guys put these batteries in like this? They were like that? I'm gonna check a couple tables to see if everybody's got them reversed like this.
Should they be reversed?
I don't know. They were, I haven't used two of them. But just check a couple tables. Check some over here. Hey, what? Uh, do you have one of the boxes?
We do not know. Okay.
How many at your table? Huh?
Is it cool if we just do a bigger group then?
Well, how many at your table?
Like just one person missing. So like a group of
Okay, these guys need a box or something. So where's the stinky box?
stinky boxes.
Okay. All right. Wait. Is that the stinky box? Give me the stinky box. I don't want you to go around with stinky equipment.
Thank you, Dr.
I'll take care of that task. All right. And a fluke. Is that mine? Does he have one? All right. Oh, this has a little bracket back here so I can tilt it upward. Nice. Seriously? Okay. All right. Good. Thank you for. Okay. All right. This is my stuff here. Okay. And I have one of those brackets, right? No, they're all right, but they're detached. All right, you want to swap me over to the document can? This is no good. I'm not going to be able to show the students what to do. Joel, can I borrow your battery pack and a bulb and a couple leads, please? Emergency basis.
Red and black, just like
Sweet. And actually, I need one more lead, please. Okay, students, let's get this assembled. Okay, take your battery pack. Now, my battery pack is lined up so that the positives are at the same end of the bracket. All right, and also I'm going to be doing this up here for you guys to see, and then I'm going to use this stinky set of batteries up here, which looks a little bit different because apparently some faculty member unknown has rifled some of the boxes. And so I have to use a stinky one. So I'm going to be using this one eventually over here because see, these ones they're not attached and they're soldered in and stuff, not like what you guys have. But I'll show you how to do it with the stuff that you guys have, and then I'll switch over to mine. All right, so positive on one end, negative on the other end. Now take a look carefully. The big bulb, the big nub end, that's the positive end. All right, and what we're going to do is wire in, and I'm going to use my yellow lead here. The high end of one bulb. Okay, so attach it to the tab. All right, and then attach it to the low end, the negative end of the other bulb. All right. Now these things are connected stem to stern, and so we got extra power. Now what we're going to do is connect the positive end over here to my circuit, and then the negative end of the other battery over here, we're going to connect to the circuit as well. And the circuit that I want you to do right now is just a single bulb. So take your single bulb. Let me try to, all right, and connect your positive end to one end of the bulb bracket, one of the posts, and get out another lead, and connect the negative end of the second bulb out to the light bulb. And when you do that, the light bulb should light up. All right. And you can actually see my light bulb lighting up pretty good. Yay. All right, so we got a little bit of Christmas light action here. All right. So now if you look at mine, just to double check, all right, my black lead is connected to one post of the light bulb, and it's connected to the negative end of one battery. Now the positive end of the other battery is the red lead, so that goes from the positive end of the other battery over to the other post. All right, and we get a nice light on that. All right, disconnect. Oh, wait a minute. Yeah, disconnect. All right, and let me give this back over to these other guys. Here you go. Now I'm going to wire up my gear, my stinky stuff. Oh, how are we going to do this, you guys? I don't even know what this is. This is like brand X equipment. We don't. How are we supposed to work with this? Oh, you got some leads there. Okay. All right. All right. I'm starting to freak out here. All right. Okay. All right. Can I have a battery? All right, let me use one. Oh, Joe, is this yours? No, you have yours.
There's only two in there.
Okay. Can you find me another one?
Another bulb?
Yeah, another bulb set. All right. So now let me get mine set up. And I've got positive. I got all these straight wires here. Let me see if I can get these out of the way. All right. So here's my one bulb. And I'm going to connect the positive end of the first battery to the negative end. Do these brackets work? These metal brackets instead of the tabs?
I don't
Now get your flutes ready because we're going to make a measurement here in a second. All right. This is primitive. This is typical physics chaos, all these wires floating around, interfering with each other. All right, let's see if we can get another. These white jobs here. All right. So did you try clipping onto these brackets or
No,
what?
I did the leads.
The wires?
Leads, yeah.
Yeah, let's see if it's soldered in, it should work, but let's see here. Ixnay. All right, I'm gonna have to try to get onto these leads here. We should have kept this brand X set wired in the way you had it. Boy, this is tenuous. This is very shaky. Boy, this, sorry you guys, this stinky equipment I got up here is really pathetic. How did you get this one? Theoretically, all you have to do is touch the solder. Let's see if that'll. All right, where's my white? Crap. Mega crap. Thanks. I don't even know. I don't even know if this bulb works. Yeah, it's not bulbs. It's these leads to the batteries. There we go. All right, so there's my. Okay, now I've got my stuff. Sorry for this forest of wires on the camera here, fellas. Let's go. All right. So I've got my red lead connected to the positive end and to one post of the battery. And now I've got my white lead connected to the other post of the bulb and to the negative end of the second battery. All right. Now, what I want you to do is take your fluke. All right. Don't do anything with your circuit. But take your fluke and switch the red over to the 20 amp to the 10 amp notch, the 10 amp jack. All right, like this. All right, so you have the black on common and the red on 10 amps. All right, turn it on. Now you're not getting jack. Oh, wait a minute. Turn it off. Make sure that you're on. Your dial is set to the 10 amp level, which is about 9 o'clock. All right, make sure you've got that. All right, so that's good. Now turn it on. And I'm going to put mine over here. And what I want you to do now, I'm going to disconnect the high end of the bulb. So that for me, that's the red. It's connected to the plus side of the first battery. And so I'm going to disconnect that. The bulb goes out. Now I'm going to plug it in. Excuse me. I'm going to connect it to the red lead on the fluke. All right. So so it's going to look like this. All right. So the red lead from the battery connects to the red fluke lead. All right. Now, make sure your ammeter is on. Now touch the black to the post. Correct. This ain't working. Anybody getting any current? You are? I can't get. Dead batteries? Um, just keep trying them, I guess. This is burning my grits. So that's good. This should work. I don't. Let's try it the other way. I'm not much of a sub genius on this stuff. Are people getting currents? Check to see it. It's these. I'm just not getting. Yeah, I'm not getting anything.
Maybe one of these are broken.
I think I got to plug. Oh, that one's not plugged in perfectly. Let's try it again. All right, there we go. All right, let me reverse this. Make sure your plugs are all the way in. That's what I was dealing with here. Okay, now look. Okay, here's my black lead from the fluke, and I touch it to the bulb, and my bulb lights up. I take it off, it unlights. Now, read your current. And write it down. And can you here? Okay, so this is number one. I1, current one, and whatever you have. Okay, now disconnect one of your leads, turn off the bulb, and let's go to the clickers. And what we're going to start doing is we're going to type in our observations. And so you've got it written down, hopefully. So keep it in your notebook. And also, can you switch over to the laptop, please? All right. So go ahead and turn on your iClicker, and we're going to type in a number. Now everybody's going to get correct on this. That's why we're doing alphanumeric instead of just numeric. All right. So let's go to the question. Compute the resistance of the single bulb on this circuit. All right. Now you have three. Who had a dead battery? Anybody? Did you get a replacement?
Yeah.
Okay, so everybody's got 3 volts. And you've got your current measurement. So figure out the resistance of the single bulb. And I'm going to do the same thing here. Which is what? Oh my goodness, what is this smudge on my... An answer to the nearest tenth of an ohm.
You have it open.
Oh, okay. Okay, answer. Go ahead and hit refresh. Type in your answer to the nearest tenth of an ohm. And I've got mine up here.
Resist.
20 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, now let's take a look at these. Yeah, there's a lot of yeah, there's a lot of variation. So it looks like there's a lot of answers, and I'll give everybody. And what I'm going to do is in the YouTube this afternoon before I publish it, I'll type in the average. I'll look at all the responses and type in the average. Now mine was 10.3, and so supposedly it's a little bit. These are called number 14 bulbs. Supposedly they're a little bit lower than that, but I saw a lot of people with up in the neighborhood of 10. So that's good. All right, now turn off your fluke for the moment. I'm not done with it, but turn it off for now. Spare the batteries. Okay. Now what we're going to do is we're going to take another battery, all right, or excuse me, another bulb, and we're going to wire these two parallel. All right, so what you do, I have white. If you can you switch me over to document cam? All right. All right, so you can see on my first bulb, the one that I had first, I have the white lead to this. This goes to the negative end of the battery. Okay, so what I'm going to do is take another white lead and connect it to the same post. All right, and then connect that to this post of my second. All right. Now my positive end of the battery is red, and that's connected to my fluke. So what I'm going to do now is take, I don't have any black. What I want to do is touch the black probe over here. Now look at this. Look at this. Look at what I'm doing. I'm going to touch the black probe to the, see, this one lights up. And you know why that is? It has its own independent path. But now look at this one. This one lights up. It has its own independent path. But what I want to do now is connect these two posts here. And since I don't have a black, I'm going to use a green. All right. Turn your fluke back on. Okay, so here's my green, and I'm going to connect that to the same side of the bulb. All right. Now my fluke, my red fluke is still my amp side of the fluke is still connected to the positive side here. The red cables, you know, I'm red all the way up to the fluke. But now over here, let's see what happens. Now I'm going to take my black probe and touch this one. Dun, 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 and look, I've got both bulbs going. All right. So basically, what you want to do is keep half of the first one wired in. That's my white one over here. Then I put another one, a white one from that post over to the same post of my second bulb. Then I connected the other two posts with a green. And my fluke is still wired into the negative end of the terminal at red, on the positive side. So now I'm going to and look, if I touch either of these posts, they both light. And what that tells you is once I connect the circuit, each of them has their own parallel reality, voltage-wise. They can each get juice from the battery. Now, so this is measuring now your current rating here is measuring the battery's the current into the battery, into the high end of the battery for me. All right? Go ahead and write that down. That's I2. All right? All right, so our next question is, switch over to the document cam, please. Well, wait a minute. Go ahead back. Before we do the next question, I see some, can you guys stroll around and see if everybody's got, everybody show Kendra and Andrew that you've got two bulbs simultaneously lighting up. And I could see you guys over there. How about you guys? Two bulbs lighting up? No? Let me, Kristen and Joy, correct? All right. See, I'm learning names. All right, let's see what you got here. Okay, first of all, this is wrong. Okay, it should go negative to positive. So, yeah, take your green one off there. Oh, you've got, okay, I see what you got. Okay, so you've got, so this is positive and negative. Positive out. Just connect that to your fluke. Connect that to the red fluke. No. Connect the green one there. All right. Okay. Now this is going, okay, so this is the positive end, negative. So it's going up here. Okay. And so, so here's what you want to do. Take this red one off there. So go red to here. Double reds. And connect it here. All right. Now try the black. Turn on your fluke. Try this post. Okay, you got it. All right. Okay. Now, another lead. Over here. Wait a minute. Don't connect that one yet. Take the black probe and touch this one now. Okay, so they each have their own path now. Okay, now yellow to yellow. Okay. Okay, now touch either one. Okay, good. Now measure your current and write it down. You guys got double light up? Okay, so all four of yous are? Cassidy, are you hogging up all the work? What? These two lame brains. I don't know about that.
I don't know what we do without Cassidy.
All right. Well, it's hard to be humble. All right. Who doesn't have two light ups? Simultaneous light ups. Anybody? All right. So you guys are good. Did you write down your measurement? Okay. That's about what I got. Okay. We're going to click it in just a second. Okay. You guys got double light ups? Okay. Are you the boss of this group? Yeah. All the gears in front of you. I mean, I'm the boss up here. All the gears in front of me. And so Canton Young is over here. He doesn't look like it. He doesn't talk much, but he seems to be the boss. He's the boss of Joel today. Good. All right. Okay, now let's do that clicker question. Okay, go ahead and type in your current into the battery from the two parallels. And if you look at the diagram up there, you'll see that that's basically the diagram of what we've got. Okay. Do you guys get two light ups simultaneous? Very good. All right. You guys too? Good. Yeah, it's not too hard. I mean, once you get the pat.
Yeah.
Okay. If you want, re-verify and type in your number. 20 seconds. Yeah, this looks about. Dots. So this is fairly close to the right ratio. So that's this one, and this one should be in this ratio. Yeah. All right. Let me shut down the question. 83 answers typed in. Very good. Um, wow. Everybody, shh, 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 shh. Hush now. Everybody's going to get dineros for this, but I'm just looking. Yeah, there's a lot of. That can't possibly be right, but we'll go with it. Everybody will get correct, marked correct on this one. Um, and what I'll do is type in the average for this as well. Okay. And raise your hand if you got something like about 0.5 something. Okay. I saw a lot of that. All right. And let's now do a couple multiple choice. You still have to type in the letter and hit the send key. Compare the relative brightness of each of the two parallels. Go ahead and turn them back on if you want. And let me start the question. So double check your brightness. Re-verify. Whoa. Okay, 20 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Go on, get your answer in, you guys. Okay. Now, another question. Now I want you to compare the relative brightness of those two parallels. Now compare that to the single bulb in the previous circuit, if you can remember it. And actually, if you want, just disconnect one of your post-to-post leads, and you'll have a single. and you can re-verify. So go ahead and type in your answer, hit the send key, A, B, or C. And hey, you guys, this one is pretty subjective as well. So I just want to see what you guys are observing. Your answer to this is correct, whatever you type in. This is going to be the tough one here. Kendra, take a look at this. And I'm going to want you guys to circulate on this one. We're going to do these two parallels and then a fore or aft series single bulb. So we're going to have 3 altogether. All right. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. All right. And as I said, yeah, see, look at, let me show you this. All right, everybody's going to get it. I'll just do it right now. Okay, so everybody's marked. But look, we got a spread of opinions. And there is a correct answer for that. So, but right now we're just doing kind of your impressions of it. And that's all right. That's a valid thing to do, and then you're in a lab and you're making a measurement, and for you guys, it might be you might be doing electrophoresis on some proteins or DNA or something, and you may have one impression and your lab partner or your co-worker might have a different impression, so you talk it over and then you figure out exactly what's happened. So it's not like it's a measurement, but it is good to compare notes, talk things over, and then maybe remeasure and stuff like that. Now, we're going to put, oh, wait a minute, before we do this one, let's assume that these two bulbs have equal resistance, okay? So for just, capital R. What would the equivalent resistance of this set be? Two bulbs, each with resistance R, but they're in parallel. What would how do you do that? How do you do the equivalent resistance for parallels? You do the 1 over R business. 1 over R1 plus 1 over R2. So this should take you about 2 seconds. You can do it mentally if you're. Who's got an answer? Canton, what do you got? 0.17? No, give me in terms of R. We're assuming we're not. I don't want your value because nobody else, somebody else might not have. Well, what is it? You got to be confident of your. Who's got an answer that they're confident of? Bradley. 5.15. No, I don't want the number. I want in terms of R. A multiple of R. We're assuming, not everybody has the same R value from the first bulb. Okay, so Bradley says 1/2 of R, which is correct, theoretically. If both of these bulbs are the same, you have 1 over R plus 1 over R. That's 2 over R total. Invert it, R over 2, and there you have it. That's half of the resistance. So that means, does that seem right with the amount of current that you got out in this configuration? Lower current, lower resistance, more current? Yeah, okay, good. Matter of fact, what should the current be in your second current measurement? Yeah, that's right, twice. It should be twice the first. Twice for the single bulb. All right, let's go to the next task. All right. And I'm going to show you the diagram that you're going to measure the current for. Here it is, and you're gonna type in the current, but not yet. First, we got to put this together. Okay, so go ahead and sketch this one out, and I'll do it with you up at the document cam. We're going to keep the two parallels, and then downstream or upstream, we're going to put that third bulb in series. All right, and we're going to see what happens with the current. All right, we're going to measure the current. See where I got my ammeter over there? Now that's downhill from my two parallel bulbs. It's going down the downhill side of the battery. And I got my single series bulb uphill of the two parallels because it's connected to the uphill side, the high side of the battery. All right. Now you could do your series on the downhill side of the parallels if you want. All right. But jot this down, and then we're going to build it. All right. Can you switch over to the document cam? Okay. Switch back. We got slow sketchers. All right. Get that. So you got two batteries in series, and then the high, for me, the high end goes out to one bulb, then over to a split, a junction that goes to two bulbs. Then they join back together. It goes to the ammeter, and then the ammeter down to the downhill side of the battery. Question? You only have two bulbs. Do you have three of these brace brackets?
No, we have 3 bulbs, but only 2 brackets.
Ooh. Does anybody have 4 of these green brackets? Anyone? Bueller? You have one? All right, here you go. Great, thank you, Bradley. All right, go to the document cam. All right. Now here's what I'm going to do. I tell you what I'm going to do. Let me tell you what I'm going to do for you. All right. I have another battery here. One of these. It doesn't have, do you have one of these plastic bags? There might be some bulbs in there. Anybody have a spare green plate? Yeah. Is that your 4th? You have 4? Okay, over here. Okay, we got one. All right. All right. All right, now how am I going to do this? Okay, my white is... All right. Now, what I've got my ammeter hooked up so that I can catch the uphill side of the battery because it's basically connected to the positive. My red lead is positive lead of the fluke, and then and then like I connected here and whatnot. So what I'm going to do is the other end. So that means, all right, go ahead and put your parallel connections. So for me, that's green and green on the uphill side and white and white. And then what I'm going to do is disconnect my white, the white that goes back to the battery. So that's this one. So disconnect. So here's my white. It goes back to the battery. Here's my white lead. Now, this white lead, I'm going to connect to my third bulb. And then I'm going to take, I I got another white lead. Now I'm going to take another white lead and I'm going to connect it. Now I'm going to go back to the white side of the parallels. And there we go. Now I don't have any, I haven't, my black lead is still my key. This is like my switch. And it's also going to measure my current. All right. Now, here's what I'm going to do. Here's my third, this is my series bulb. And these two are my parallels down here. All right. So these two babies down here are the parallels. Now look at what I'm going to do. I'm going to connect, I'm going to touch this end of the series bulb. Now if I touch this end, it doesn't light up. But if I touch this end, it lights up. All right. So that means that is running. It's also connected to the white end of my two parallels. So now all I have to do is connect my probe to the green end, the far side of the parallels, and this should light up all three of them. Well, let's see what we get here. Dun, dun, uh-oh. Dude. Look at this. This is all connected. But now notice that bulb is fairly dim. Now here's direct. Okay. Very bright. Much dimmer. Yeah. So what I'm guessing is these two are not even lighting up. Let me see. No, they're not burned out. They were just working. Let's try. Oh, wait a minute. No, I got it. I got everything. I'm getting. It is going through. And I'm. Okay, guys, take a look at what I've got. Is anybody in this situation? You're wired in, and your series is lighting up a little bit. Now here I am. I'm at the downhill. I'm at the far side of my parallels. See, my series bulb is lighting up. If I can keep this. Now look at the brightness of it. Right now, let me go directly to the other post of the series, and look how much brighter it is. See that? Now visually memorize what I've got here. This is my parallel directly to the battery pack. And it's very close to my original voltage. Now here it is coming out the other end of the parallel, and look, it's much less bright. So my guess is that we're not getting enough juice through these two parallels for them to light up. And the way to check that is to See now, they're lighting up because this is my original configuration. 2 parallels. Now I'm going back to my combo, and you know what it tells me? It tells me that I have more resistance net, so that current is less. And in fact, measure your current. Go ahead to the far side of your parallels and back to the battery, which you should already have, and write down your current. And I'm getting a current that's the lowest of all. Now, here's what I think is happening. All right, here I am. I'm lighting up. I don't have much current. And there's a good amount of work being done at this first bulb. But I'm not getting much done at parallels, at the 2 parallels. I don't think that it's like, now if this room was completely dark, it might, actually, can you see if you can darken the room with the lights? Let's see if we can turn the lights off. Isn't that up here on the, all right, let's try it. Let me, Kendra, does this have a light? All right. Now I need a little bit of light. All right. All right. Now here's my series bulb. And you know what? I don't think they're lighting up. I think that's just reflections. Yeah. Turn the lights back on. All right. Can you flip back to the laptop? All right. And flip back to the dot cam now. Because I accidentally turned it off. All right. So so unfortunately, we're not getting enough work done over here on these 2 bulbs. We're getting current through them, but we're not getting enough. It's not enough to really brighten things up. But definitely write down your current, get your current measurement from your fluke and write it down. So this will be I3, current number 3. All right. Turn off your fluke. Emily. What's that? Oh. All right. I'm going to open up this question. Go ahead and type in your current. Now this one is supposed to be what's the scoop?
I have one where this bulb is turning on, and when they touch the feed to it, these turn on, that one turns off.
They've got a short circuit.
Yeah.
And you're not going to be able to show it on with this stuff.
This is your positive, right? So you're
Yeah.
turning it off with this.
Yeah. That's my
So
switch.
but
I just want to see your battery up close. So, because we were getting like 2 different things, like mine, we were only able to get 1 light bulb to light up. Then the people next to us were able to get all 3. But they had like on one end of the battery, they had 2 connectors.
Yeah, so that's,
It's not what you were doing.
no, that's not, that would be a 3rd parallel. Yeah.
So just getting the one is okay. Light up.
I think so. That's what I've got. Mine's parallel. I've got two parallels seriesed up with a third, and the third's, see, here's why.
It's just like with all the wires. So
I know
like,
it's tough to
yeah.
it's tough to
That's why I
follow.
wanted to see it up close.
Right now, this is my switch basically. Okay, now take a look at my flute. Now, okay, I'm getting current out of this post and into the battery. All right.
Which ours is like around
Yeah.
the same.
All right. And it's lighting up over there. Now, so that means current's going through this one, right? And I'm getting current through that one.
Yeah.
All right. And notice it's about the same value, but it's not lighting up.
Yeah.
And so my guess is that there's not enough voltage drop left here to light these babies up. Because they got to,
Yeah.
yeah,
It has to be enough.
like with a flashlight, it'll get dimmer and dimmer, dimmer
Yeah.
as the batteries run out. So,
Yeah.
so I think that's what we got here. So yeah, current, and it's the same, because look at the brightness of the series bulb.
Yeah.
So, all
Okay.
right,
And so then in order to light up all three, you would have to do another connection
or
probably.
maybe another battery. So they're supposed to be rated for 1.5 um, 1.5 volts for 100% brightness. So, but it really depends on the current.
Yeah.
So,
Okay.
all right,
Thank you.
you're welcome. Okay, 10 seconds to type in your current measurement. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Okay, get your answer typed in. And hit the send key, please. Let me get a drink of water. Okay, I got all the answers. And yeah, I think it's the bulbs. They need a little more. Yeah, yeah, we're getting current on the downhill side of these two bulbs, so we know they're getting current, and it's not much, but and in fact it's split. So right. Look at Kendra. Yeah, this thing is a mess. Yeah, just you could. Yeah, you can disconnect all that stuff. Get it ready. Actually, time out. Let me switch over to. Okay. All right. Let's get our stuff put away. So take your box, disconnect all the leads. They've done their job for today. Thank you, leads. Yellow lead, done. Yeah, yeah, go ahead. Okay, take your box, as before. Put your batteries in one corner, and you have the double bracket. I have the single, two singles. Then put one battery or one bulb on top of each battery, and then put the third bulb down to the side, like this. All right. Then get all your leads all tangled up and get them squared away. As much as you can. And just kind of loop those in there. And then take your plastic bag of supplies and just put that on top. Then find your lid and snap the lid. All right, when you've got everything put away, to make sure your fluke is off, coil the leads around the fluke and bring it on up. Bring everything up, return your gear. Oh. What? Yeah, I think so. I think that's, yeah. Most of the work I've done there, not enough work left for the other two. I think that's probably a good way to explain it. Because, the delta V is equal to IR. They all have the same R. Okay. But if you're not getting a lot of delta V, you're not going to get much work done. And work is done, and work is dissipated through heating, basically, at the bulb. It gets hot. And they're not getting hot enough. So another way to think about it is the current, actually, let me get back to the discussion. Dr. B, tell me ask me, Dr. B, what's that other way to understand the no lighting up bulbs, okay? Just ask me as soon as all these guys are done and I get back to the podcast, all right? So,
What is the other way to
yeah,
get the light bulbs to
yeah.
light up?
Don't let me forget.
Okay.
Yeah, you're welcome, John. All right. And can you guys, is this a zip zap battery over here? No, that one. Was that a? Okay. Anyways, take care of my stuff here. Okay. Okay, my wonderful students. IQ test. The two parallels over here. Get my cursor back over here. Okay, these two parallels. Same current or different current through each? Same current. Who votes for same current? Who votes for different size? Who's not voting? Everybody over here. Come on, you guys. You got to think. All right. And the answer is for this question is theoretically they should have the same current going through each of those. All right. Because it splits right here. Now, what's the equivalent resistance of those two? We already did this. The equivalent resistance of these two babies in parallel. Come on, we just did it a few minutes ago. Yeah, it's 1 over R plus 1 over R equals 2 over R inverted. It's R over 2. So it's 1/2 R. Okay, and then this is 1 R over here. So the total equivalent resistance here is 3/2 R. Now what that means is the batteries are the same. So same batteries, bigger resistance, less current. Now listen, Gianna, because we're about to explore why those two parallels didn't light up very good. Right? They were getting current because you guys measured current through those two parallels. You're basically getting 2/3 of the current out of the battery because you have 1.5 times the resistance effectively. Okay, you have one R here and then 1/2 an R equivalent here, and that's in series, so it's 1.5 R total for the total equivalent resistance of this system. So 3 over 2 times R means that the current is 2 over 3 times the single bulb current. Okay, so the single bulb current is kind of our standard. So relative to the single bulb, these batteries are losing 2/3 of the whatever the single bulb current was. Okay, and we all measured that. Now, it splits here. It splits right here at this junction, 50-50. So now you have in this upper branch 1/3 of the single bulb current and 1/3 of the single bulb current down here. And that ain't enough to light that up. And Gianna, that's another way to explain why those two bulbs, if you had it wired in correctly, current was going through them, and we couldn't get the room dark enough to show, they might not have even been glowing. And you know, when we have a flashlight, when the bulbs are starting to go bad on you, you know, you're walking past the graveyard, and it's a really big graveyard, and you have a good full bulb when you start walking past the graveyard, and it gets scarier and scarier because your flashlight's getting dimmer and dimmer, especially if it's in a movie. And yeah, well, zombies or something, you know, it's always something. But anyways, your bulbs get dimmer and dimmer. Your batteries get lower and lower. Your bulbs get dimmer and dimmer because there's not much current going through. There's not much I squared R heating, and heating is what, you know, lights up an incandescent bulb. Now, if we had LEDs here, that would be interesting. Yeah, because LEDs, you have the right voltage, bam, they're going to light up. So that would be interesting to do. I'd have to think about that. Anyway, so that's the answer to that particular question. So what we're going to do, let me get my cursor back over here. I'm going to compute the averages, and we'll try to analyze those later and see if the averages make any sense. Okay, and mine do. My three currents, I1, I2, and I3. I2 is supposed to be 2 to 1 with the single bulb current. Two parallels by themselves, equivalent resistance R over 2. So the current has got to be 2 times I1, the single bulb current. So, but we'll analyze. I'll look at the averages and see if they make sense. All right. Now, I want to talk about the mini review or the mini lecture that I provided on Monday night concerning the discharging capacitor that we talked about a little bit. So I have one more question for you. Hit the refresh key. This is just multiple choice. Hit your refresh, and actually, I take that back. This is going to be alphanumeric. Hit your refresh key, and again, and I just want to see how many of you tried it out. Either way is fine. You'll get free points on this, or everybody gets a point. You tried out the Excel spreadsheet or not? $15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Well, Amber Alert. That little kid. All right. It appears that even though that thing was up fairly early on Monday night, there's a lot of slackers in here that didn't look at it. All right, but we're gonna kind of look at it today, and for those of you that did look at it, that's good. And if you know how to use spreadsheets, you can basically fool around with it. Here's what it looks like. This is in Apple numbers, which is what I use. Then I export to Excel spreadsheet. Now let's just review the stuff that we were talking about at the end of class. We talked about a discharging capacitor. So here's the charged up capacitor at T equals 0. At T equals 0, the last of the current, it's going counterclockwise. It's loading the right side plate of the capacitor from the battery. Okay, so current's flowing counterclockwise. But after the last electrode loads in at some bigger amount of time, you take the battery out and put in the resistor. So you throw the switch, and then you swap the battery for the resistor. Okay, and so now you've got some energy stored up here in the capacitor. You got a set amount of charge, Q, Q0, and that corresponds to a certain amount of energy, certain electric field density stored inside between the parallel plates of the capacitor. So this is the charge state. And if you think in terms of defibrillators, a defibrillator is about to be used. All right. You are the resistor if you're getting defibrillated. And the switch is the guy at the machine that when you say clear, and then he goes, bam, he hits the switch, he hits the button, and it closes the switch, and then it starts to discharge. Okay, and when it does, you have clockwise current, all right, so it reverses the directionality of the charge up, and eventually it's a function of time, and as we mentioned, it eventually goes to 0 when the value of t gets very, very large, because the last surplus electron is just kind of poking out of there. Doesn't have a lot of stuff. You know, the first few electrons, they're blazing because they've got a lot of stuff. They're trying to flee. You know, they're getting pushed out. This guy's just kind of like a slacker. Now, the conclusion we came to was this equation at the bottom here. Here it is. Delta Q over delta T is proportional to Q as a function of time. And so in terms of an equation, you just write equals some constant of proportionality alpha times Q of T. All right, now that's where we're going to start today. Delta Q over delta T equals alpha times Q of T. Now Q is a function of time. And delta Q over delta T, that's actually an approximation of the current. Okay, that's the slope. If you look at the curve of Q over time, delta Q over delta T would be the slope. And numerically, that's the current, charge per coulomb per second. All right, now when you see an equation, as I mentioned in the little mini lecture, when you see an equation that looks like this, delta something over delta T equals alpha times something, think exponentials. So it's gonna have some constant and then e to the plus or minus alpha t, you know, depending. All right. Sometimes in some physical systems you have plus alpha t, some you have minus alpha t, sometimes you have both. All right. Now, for the spreadsheet, the way that you can make this work for you in a spreadsheet is simply this. Figure out, declare an initial value of Q, declare an initial value of alpha, and declare a set value of delta T. So take snapshots every 10th of a second. Okay, that's your delta T. And that's what I did in the spreadsheet. I used alpha of 2.5, initial charge load of 1,000 coulombs. It's a pretty big capacitor. And then delta T, this is my bookkeeping decision here. I can make it smaller or bigger depending on what I want to do. And I can compute this at every stage. And what that means is I can figure out delta Q. Now delta Q is Q2 minus Q1, Q3 minus Q2, Q4 minus Q3, all the way down the table. So this thing here allows you to put together a spreadsheet, which is what we did, and figure out the time evolution approximately for Q. Now, here's the spreadsheet that I set up for you guys. All right. And so what I did up here was I said, all right, let me give an alpha of 2.5, and it's in inverse seconds or hertz, and then a charge load. You know, so we charge it up, and we charge it up to 1,000 coulombs, and then we analyze it. We analyze the discharge. And RC is 2.5. And I just chose some nice round numbers here, 1/10 of a second for my fiduciary delta T over here in the left-hand column. All right, so I have this, time equals 0. I have the initial value of Q. And then I can figure out, because I know alpha and delta T, I can figure out the initial value of delta Q over delta T from that formula. Then I just multiply that by delta T, and I get negative 250. And that tells me how much in the first 1/10 of a second, approximately, the capacitor discharges. It discharges 250 coulombs in that first, and that's a lot, in the first 1/10 of a second. That'd be big enough to kill a person. All right, so this is kind of unrealistic. But anyways, that's how it works. So then at time t equals 0.1 second, you know approximately that you've got 7,500 or 7,950. You don't have 1,000 anymore. You've just dropped 250 in that first 1/10 of a second. So now you do it again. You calculate delta Q over delta T, multiply it by 0.1, and then subtract it from 750. Now you're down to 562.5. And all the way down the table. Now, if you look at the spreadsheet, and I highly suggest that everybody in here does it, and you're not required to do it, but on Wednesday during the midterm, if you've looked at this and messed around with it, you may find yourself smiling a little bit. Okay, so it's optional. I'm not going to have a homework question about it, but I highly recommend that you look at it as a study tool. All right, so there's the, and I posted it in discussions. So there's the file name, discharge-time.dependence.xlsx. So you can use that in either Apple Numbers or Microsoft Excel if you have a Windows machine. All right, so here's what the numerical approximation. Starting at, and notice I start up here at 1,000, and then my next one approximately 750, and then this is 522 point whatever it was. And then, I keep going down here. Now, I mentioned to you, if you do the reading, that there's another numerical factor called the half-life. And for this, and if you read in chapter 31, I think it's section 5, which is mentioned in the YouTube, you'll see how to calculate that. It involves logarithms and stuff, natural logarithms. And it's about 0.28 for this system. And that means that after 0.28 seconds of discharge, you should be down to about 50%. Now, 50% is 500. And so you could see that, this is where you're supposed to be at 0.28. But this numeric approximation hit the 50% level, 500 coulombs, a little bit early, but fairly close. It's not too bad. And the reason, of course, for that is it's a numerical approximation. Right? Then I calculated, and you can look it up in the book, and they have the exact formula for the exponential form. And it's this blue line. And you can see how close the blue line, the exact solution, and the numerical approximation are. They're fairly good. Pretty good for government work. Right? And a lot of times in physical systems, you have to do it with spreadsheets and stuff. You don't have an analytical solution, as we say. You don't have an exact formula. So you just kind of, use delta t, smaller and smaller, and get closer and closer to the true curve, hopefully, and go with that. Now, in this one, I mentioned last time that as t goes to infinity, i.e. out to about 5 seconds, relatively speaking, the Q value on the capacitor goes to 0. And at that level down there, I think it was down to the last 1 coulomb when I cut off the table and graphed it. Now, the next thing I want to show you before we dismiss is the discharge. Now is the charge up process. So this is when you connect the battery to the capacitor, all right, and with a resistance, and then charge it up. All right, so this is the exact exponential solution. This is called the saturation curve. Go ahead and write that word down. And if you think about it, this is just a vertical flip-flop of the first one. It's exponential decay for discharge, and it's exponential saturation. It's not exponential growth, though. Don't say that this is exponential growth. This is a saturation curve. Okay, and asymptotically, here's the formula for it. So maximum charge, 1,000 coulombs, times the quantity 1 minus e to the minus alpha t. That's your exact solution. And you can see that in the textbook, all right, at the end of chapter 21. And this one, again, has asymptotic behavior. And I looked it up before class. That value up there is approximately 997.52 coulombs. So it's almost up to 1,000, and it's only gone 2.40 seconds. All right. And as the time goes bigger and bigger, formally we would say as t goes to infinity, the charge load is going to get closer and closer and closer asymptotically to Q max, which is 1,000 in this problem. So So that's what, in the problem that we worked, we discharged it. So, and this shows how it would charge up again. All right. And then you do it again. You discharge it and then charge it up again and then discharge it. And you get a series of these saturations and then exponential decays, then saturation and then exponential decays. And you can cycle it back and forth. And then actually, this is how blinkers work, this kind of curve. Question. This is a charge up curve. Yeah, it's a saturation curve. It's charging up to 1,000. You see that? Discharge is the other one. It's losing current. It's losing charge. Now, the slope of each of these graphs, the blue ones, is the current. All right, the change of charge per unit time, coulombs per second. All right, now, before we dismiss, I want to, let me get my cursor over here. Try to read carefully the last section of charging and discharging capacitors in chapter 21. And then Friday, we're going to start talking about magnetism. So start reading and skimming the next chapter, and we'll start with that on Friday. All right, and that'll probably be the last chapter before the exam. You're dismissed.